Hey YouTube, it's Taylor again. I just thought I would post a quick update. Right now I'm printing a part on the Black Widow. Black Widow is my big printer, and this part is the same diameter as the width of Rovers frame. Let me show you what I'm working on here. So this is, let's see, this is the gearbox assembly right here. So that's the normal Rover gearbox. Looks kind of like this. You've seen this before. This one's a little, well, all the other gears in this one failed. So I'm working on testing new gears, and I've got stuff going on like metal pins in here. I've also been, let's see, testing bronze bushings. So this one has a nice bronze bushing on it like that, so this one spins really nicely. And the thing is that every time the gearbox fails, if I build 4 gearboxes and then install them on Rover, make sure they're all calibrated and Rover is functional, and then go take Rover out to a park and drive it a few kilometers till everything fails, it's a huge amount of work. And so what I'm building, this big cylindrical part here, is this part here, and I'm making a test stand. So you can see the gearbox is installed here, and then I've already started printing pieces of it. So this is that jacket that goes around it. The way that works is the gearbox is going to bolt in like that, and the motor will stick out the top, and then the drive will be on the bottom, and that goes into this bucket. And then I've got this thing from the hardware store for mixing up drywall mud. It's called a quick mixer, and it's just this metal mixing device, and I've made the bucket the right dimensions for this thing, and I'm going to put sand in the bucket. So I'm gonna just mix up sand forever, and the whole point of this is that instead of making 4 gearboxes and then taking it all out into the field to see which designs work or which designs fail, like I don't know if I should just do metal pins going into plastic like this, or if I need to use these bronze bushings, or if I should actually use ball bearings. And I've got some small diameter ball bearings in the mail that are going to still be able to fit inside of this gearbox. One of the big constraints on this gearbox is the inside diameter of the tire. So here's the tire. This one is full of a bunch of totally messed up gears, stuff that I just had to use cutters and pliers to pull out the failed gears from the gearboxes. But because these tires have a really thick sidewall, the actual inside diameter is not huge, and this gearbox takes up all of that space going inside there like that to turn it. And so I can't just put, you know, nice big bearings in here, and I've been trying to figure out how to keep the bill of materials as simple as possible while making the thing last. I want to go 50 kilometers between mechanical services on the gearboxes. Ought to be plenty possible, and any less than that and the thing is just a curiosity or a toy. I don't want it to be a toy. I want this to be a robot that you can program to go outside and do some kind of a work, whether that's surveying, or maybe put a plow on this thing, or shoot out pesticides or herbicides, whatever it is you want to do with a robot out in the field. The whole point is I want to see what you can do with a 3D printer at home, and hopefully make a robot you can make in a small shop that just requires a $1,000 3D printer like this one here. So this is the TiVo Black Widow. There's some other printers that I might recommend. The Black Widow has a lot of assembly work. I do like the TiVo printer. I like the strong frame here, but it does a lot of assembly work, so typically I recommend the CR10 printer. But there's some other stuff. There's a Tron XY printer that looks really good. This is a maximum dimension of 370 here, although part of that is the way this is mounted. This could be modified to go up to 400 wide, but I would recommend, if you want to print Rover, to get a printer that can print 400 millimeters in at least one dimension. So the Tron XY 400 millimeter variant, or the CR10 400 millimeter variant, would let you print all this big stuff. It'd be even bigger than this printer, which is only 250 in this dimension. Well, this is 225, so I think we could go to 250. And this is a radius part, so actually the part's going to come out a little farther. Yeah, so you ought to be able to make all this, make Rover on a $1,000 3D printer. I've also got smaller robots that use a smaller printer. The printer that I keep almost wanting to buy myself, but I really have enough printers and other things to spend money on. But the printer that looks really exciting to me right now is the TiVo Flash. The TiVo Flash is anywhere from $225 to $335, depending on the options. And it's a nice printer. It's more like my small printer that I have under here. This is an i3 style printer down there. Of course, this is a giant i3 style printer here. But anyway, I might check out the TiVo Flash. But yeah, I just wanted to share, that I'm making a test stand for my motors. So the point is just spin the motor, mixing sand in a bucket until the gearbox fails. And I'm going to try to write some software so I can record exactly how many revolutions it took and take the diameter of these tires and figure out a rough estimate for how many kilometers it would have gone and see where it fails and improve it. So test these parts offline, and that way I don't have to build 4 gearboxes and put it all on Rover and take it out into the field. I can build one and have it just testing away in a quiet place somewhere. So that's what I'm working on now, and hope you enjoy it. If this is interesting, please make sure to check out the website reboot.love or subscribe to this YouTube channel. Thanks.